Hi, everybody. My name is James Knight, and I'm Global Director of Media Entertainment at AMD. A little bit about myself. I come from a production background. I've been working in media and entertainment for about 20 years, post-production, visual effects, real-time visualization. I'm an Academy member, a BAFTA member, Visual Effects Society member. Very often, AMD, Intel, NVIDIA, Dolby, Panasonic, anybody providing technology to the media and entertainment business will hire professionals from the vertical to bridge the gap between content creators and technologists. And so that's my role, to recognize and implement technologies like Visioneer's AV1 encoding. So that's kind of why we're on the stage together, but a little bit more on that in a little bit. And sorry to be looking at my phone. I'm not texting. We can't see notes, so I'm just going off of this. But it was about a year and a half ago now, my team recognized why a collaboration between Visioneer and AMD EPYC would be such an insane combination, given the fact that we have the most performance densest CPUs on the planet. Let me do the clicky thingy. Here we go. It's not working.
It's working.
Down is up. I didn't want to assume that all of you knew the areas within which AMD is involved. So you can see cloud network, hyperscale supercomputing, 5G, comms infrastructure, AI, analytics, adaptable intelligent systems, gaming, simulation, visualization, smarter client and device edges. We're everywhere. Consoles, render farms. And I'd like to say that in terms of media and entertainment, we've covered the most ground we've ever covered during the last 3 years. And the pandemic really sort of accelerated the need for high-end compute for content creators and CDNs, content delivery networks. And so we've unearthed, and we now are winning in terms of rendering, content creation with DCC apps, digital content creation apps, 8K editing, and rendering at the highest levels, as you guys will see if you come by our booth. And so AMD EPYC really, really does what you've read about. It's very hard to convince the masses that AMD EPYC performs as well as you read about during a pandemic on 2D screens. You have to go on what you can see, what you can touch and feel. And we hope that NAB 2022 and showcasing such partnerships as with Zoe and Visioneer will really drive that home for you guys, and you'll get to see why we're doing what we're doing here today. Here we go. So AMD and Visioneer. Why is AMD partnering with Visioneer? Well, AMD understands the fundamentals of the creative process in professional content creation. We also understand that artists, directors, and producers will want you to see the content at the resolution, the fidelity that they created it at. The same is true of live events. Why not watch your favorite sports league in 4K or 8K? It's like looking through a window and almost being there, right? So I wanted to share a quick story to make this more human. On February 13th, like many of you, I watched the Super Bowl. And just a little bit, you can tell from my funny accent that I'm English. So I actually watch a fair amount of English Premier League football. But I watched that in 4K. Some of the matches are in 4K here in the United States. And when I was watching the Super Bowl on February 13th, I couldn't find it in 4K anywhere. It wasn't broadcast in 4K, at least not to homes. I couldn't find it. And I thought to myself, the industry doesn't know what we have yet. This is our coming out party, okay? The barrier to entry to broadcasting and encoding 4K content, it's much more attainable, it's much more cost effective now, it's more performant, and it takes less power, and that's what we'll show you today. And that's why we've bridged the gap with Zoe, and you'll see here why a partnership between AMD and Visionula makes sense. So I want to pass it over to Zoe, who I might tell you is one of two people who wrote the AV1 codec. So she's belligerently intelligent. So enjoy her talk.
Well, thank you, James, and thanks for the AMD team. And we are Visionula, a small startup team, about 4 years old. And I have to say that I was honored to have our team to be able to join with AMD to give this presentation. Also, thanks for the NAB Streaming Summit. And for AV1, as James mentioned, I actually was just one of the early engineers to be able to get involved in the AV1 standardization in the early year for 2015, all the way until AV1 was finalized in June of 2018. So it has been almost 4 years. But think about the 264, the AVC standard. Right now, it's almost 19 years. Still a lot of things are going on. So AV1 is still new. For this talk, we mainly just want to see what the potential of this new standard running over AMD machines can bring to the community on, for example, VOD, live, and extremely low delay like RTC use cases. So today we just want to show some potentials, and also for AV1, we are actually very grateful for the whole community's effort. So this is AV1's open source codec standardization that mainly has been rolled out by the organization called Alliance of Open Media. So in this slide, it shows all the members. And it's also just saying that the zero version of AV1 back to the very beginning was actually branched out from LibVPX VP9. And by now, it has included more than 100 coding tools. So what can AV1 can do? This is the current ecosystem status of AV1. For any new codec standards, you really want to see what about the playout, the player side, the decoder side. So we list up all the public info. What about the hardware decoder support for AV1, and about the CPU, GPU, basically silicon. And we list out all the current support together with mobile phones and TVs. Indeed, the TV side, all the major TV brands has already rolled out their product supporting the AV1 hardware decoding. Meantime, before, it always happens for any new codec standard, before the wide support by the hardware, there's always open source software encoding and decoding support. And we list out quite a few software decoders. In particular, we want to mention David. That is the open source software decoder rolled out by Videoland. And they actually have rolled out quite some iterations supporting decoding on the even mobile phones. We're going to have one slide to show what the capability of this software decoder. And it's also right now supported by a lot of browsers. And people are still wondering, what about some others? When are they going to support AV1 in a lot of some other devices or browsers, or on one side of the mobile operating systems? We can only say that there's quite something that can be expected for the year for 2022. And here, we basically, on the other side, for AV1 streaming is actually AOM has recently rolled out the ISO media format banding proposal is actually really support AV1 for Dash, pretend for HLS, for CMAF. And on the DRM side, it's really getting ready, quite codec agnostic, and also it supports HDR, HDR10+, and it's very flexible. For AV1 bitstream, you can insert the metadata for HDR, either on the per frame or keyframe, or whenever the metadata changes, it's all being supported. And from this slide, we just want to show some of the performance that AV1 can do. A lot of people, I think back to 2018, at the very beginning, January, the Moscow State University rolled out some data about AV1. It really showed a great coding efficiency. However, it left the impression to the community that AV1 can really code very efficiently, but it is relatively slow. We want to see in this slide, this is slides data we collected over the AMD EPYC 16 core, 32 thread. We mainly compare as an example of our very numerous Aurora1 AV1 encoder, but just as a representative encoder implementation of the whole AV1 community against the X264 medium. And in this slide, we mainly also show what if we do multiple renditions concurrently on one server. And we actually chose 20 1080p 60 videos. And because, for software encoding, the video content really matters. For some content, you can encode faster, some is relatively slower. So we chose all kinds of different characteristics for the 20 videos. Also, the bitrate matters. For each of the video, we actually chose 4 to 5 different bitrate levels to roll out the good, sufficient quality. So there's quite some streams we have to try out. For each of these instances, we try to encode multiple renditions at the same time. For example, for 2 concurrent renditions, meaning that on the same server, there's 2 encoding concurrently happening. If the encoding speed is fast enough in terms of frame rate per second, no slower or no smaller than the source frame rate, for example, 60 frames per second, you can encode in that speed or even higher. That means you can do it live. So this is the background. And in this figure, we basically show that is, for example, compared against X264 medium and using our encoder as instantiation of this AV1 codec standard, we can indeed go faster. While maintaining this faster speed, AV1 maintain the standard advantage in terms of coding efficiency. So basically, you can see that there's about more than 40% bitrate savings that can be achieved compared against X264 medium, and also it's faster. This is, we would say, this is just an example to showing that this standard can really make faster on top of these AMD machines compared to the predecessor standard, and also there's quite some potential ongoing. So next slide is compared against X265. So here is mainly compared against X265 medium for the mainly live and faster vault scenario. This is also over a typical testing set. It's object one fast compare. It's basically constant quite some different resolution like 1080p, 720p, and 360p, and compared with very, here is we showed both the coding efficiency in terms of BD rate in different metrics like PSR, SEM, and VMAP concurrent at the same time. For this one, it shows that a little slow than X265 medium, but maintains very good coding efficiency, more than 35% in various codec metric, like we just mentioned. On the next slide, we really want to see what can be done for 4K. And in this one, we did a little bit experiment running the AV1 encoder, our Aurora1, over 2 servers. One is the AMD EPYC 7763. That was a quite recent model with 128 cores, 250 threads. On the other side, the Intel 8380 that has 40 cores, 80 threads. So we just want to see what is going to be the performance. We chose one 4K 50 frames per second crowd run, and letting this run multiple renditions. So what if we try 2 or 4 or 6 or 8? So for example, when we run 8 concurrent 4K 50 on different servers, we can see that on the AMD machines, we really achieve more than 60 frames per second encoding speed for each of the 8 4K. So for this scenario, it really shows that it's quite possible. Of course, this is just for this specific video, even though it does have some complicated things, and there's a lot of textures ongoing in each frame, but it just basically shows the great potential that AV1 has the capable running on one single AMD machines to encode live 8 4K 50.
Which I want to point out, that's unheard of, to do 8 4K streams at 60 hertz on one CPU. That's ridiculous.
All right, thanks.
It's the absolute bloody truth. It's the absolute truth. So these type of conversations were going on in the background. You guys all have 4K TVs in your houses at the point you do because this type of collaboration happened in the background. Well, think about 8Ks next. Well, that's what we're doing here is the barrier to entry to create and broadcast 8K content is going to be so much lower now because of such partnerships. Anyway, sorry to interrupt, Zoe.
No, sorry. Thanks for the addressing. And we like to, because we just mentioned that the technology is a little bit, because AV1 has more than 100 coding tools as opposed to its predecessor VP9. And also for the encoding optimization, of course, there's still some traditional encoder optimization still ongoing. For example, there's so many more modes. How do you fastly choose the best mode like partition, transform, and also on the entropy coding wise. On the other side, a lot of people talk about what machine learning can do for the encoding optimization. And if you really want to learn about those instances, we always very appreciate the open source community work. So you can just simply, for example, download the open source AV1 codec called LibOM, which has been mainly maintained by Google and AOM Media, the organization behind the standard, and just check the keyword neural network. You can see there's a lot of submissions down there in that code base addressing how to use machine learning to further optimize the encoder. It's a traditional framework of the two-dimensional transform plus motion estimation, but there's quite some possibility you can leverage the use of machine learning. For example, in a lot of open source or just the encoders, you always have some hard-coded number down there. For example, at what kind of threshold you can go which code base to really speed up the encoder. Whenever such things come into being, actually it can be directly replaced by a machine learning approach because you can do a lot of prior analysis and also along the way of video encoding, you collect the stats and really train some neural network approach to adaptively set up those thresholds instead of hard-coded. Most of the time, you can get better results either in coding speed or coding efficiency. However, we are not talking about the deep learning. We're talking about, for example, maybe only 2 or 1 middle layer, with each layer have about 100 or 200 or 300 nodes. With those kind of simplified neural network, you can get pretty good results. So here we just show that what kind of module inside of the encoder, you can leverage that technologies to make the encoder even faster and more coding efficient. And next slide, we talk about one example of the AV1 codec standard to make it stands out. So AV1, for the first time to encode the film grain in its main body, this film grain tool was initially proposed by Netflix. And there's quite some encoding approach that you can leverage the use of the film grain because you can basically at the encoder side, the standard allow you to basically estimate the model parameters of the film grain model, and you only need to encode those coefficients in the bit stream, while on the decoder side, leveraging the model parameters to reconstruct and synthesize the film grain added back to the decoded video. And there's, of course, a lot of challenges for the encoder to even get that on the encoder side. For example, if anyone familiar with the encoder optimization, you can think of a lot of like temporal filtering, optimized B, or inter prediction, because those things sometimes make the model and also the synthesis of the film grain harder. The reason because you really want to synthesize the film grain in a random way, and also want to make the shape and the strength of the film grain in a consistent way along the frames. But a lot of sometimes, for example, if you do some temporal filtering on certain frames instead of every single frame, you will see inconsistency of those film grains in the decoded and rendered video, which doesn't look nice. So there's a lot of things you need to do to really get into the encoder optimization to make this film grain to really works. So the next slide will just show that even for some smooth areas, if you don't do the film grain really well with the compression added, you end up with bending artifacts. So even in those smooth areas where there's no texture masking happens, actually sometimes you need to allocate more bits when the film grain is deployed. So here we just show that you have to do some region analysis on per frame basis, also across different frames. And on the other side, there's another thing we want to keep in mind. Oh, before that, this we want to show that is because we really want to, it's really like the last slide. I want to stay in this slide. So this slide basically means that right now, anyway.
Yeah, I can do it if you want.
Okay.
I'll just keep it there. How about that? I love that we come to NAB and we can't see the speaker notes. And
it's okay.
Sorry about
so
this.
that slide, okay. Well, I'll just quickly ramp up. For that slide, we want to show that is by today, we're not doing any ads. We just want to show some fact that AV1, at least from our product, has been commercially launched more than 10 customers. The reason we want to mention that is it is not just on the research stage. It's really being deployed because of this codec standard running, for example, on top of AMD machines. And we have to keep in mind that before the hardware decoder widely deployed, we have to rely on software decoding. So when there's only software decoding available, you have to consider what we can do on the encoding side. So besides encoding speed, computation resource optimization, and coding efficiency, if you keep the decoder complexity awareness on the encoder side, you actually can compromise some of the encoder performance. For example, you can turn off proactively those hardware decoder side very computational complex tools, sacrificing a little bit of coding efficiency, but can potentially make the decoder complexity much less to make the decoding and the playback really smooth. So we add one more layer to make AV1 deployable called decoder complexity aware encoder optimization. Oh, that's about that slide. Here we want to show, thanks to James, we really say, at least in this slide, we show that besides that, there's a potato things we can also include in the encoder side to make ABR multi-rendition work with a maximum bitrate constraint. You can roll out the best encoder parameter optimization to choose, for example, the best CRF, resolution, and bitrate combination to roll out that rendition when multi-rendition is being served. And the next one, actually this is the last coding tool we want to mention, that is AV1 is the first codec, also standard, including the screen content coding tools in the main body. Because right now we have a lot of screen content talking about not only the PowerPoint or screen sharing during real-time communications, but also, for example, live streaming of game and live streaming a lot of computational or computer-generated content. They can all categorize as screen content because they are computer-generated, they're very different content. They can leverage the specific coding tools by this new standard, getting really coding efficient. So here we again compared against X264 super fast and showing that, yes, AV1 is running slow, about 3 times slow, but still real time for 1080p 30, and really only need less than 1/5 of the bit rate to roll out the same quality. For example, we have 3 additional minutes, by the way, because we start 3. So I want to leave enough time. And here, X64 medium encoded as 800 kilobits per second. For this 1080p, it's called Wikipedia. It's just a video showing that people are scrolling down the browser and using AV1 with half of the bit rate. I really want to scroll this time. Yes. So this uses half of the bit rate. But I hope you can see this is 800 kilobits per second for using X264 medium and AV1 at half of the bit rate with, I would say, significant better in terms of the substantial quality. Okay. I want to
actually see the
yes,
text
now I finally.
more clarity.
So that's all about AV1. For any questions, feel free to ask us afterwards.
By the way, I didn't mean any disrespect to Dan and his team. I wanted to talk with C-3PO from Star Wars, and we couldn't get a bloody DVD player working, so it happens sometimes, right? So, but if you guys really should come by the AMD booth, and we can get more granular with the success that our two companies have had together. We are in the North Hall at 10:15, and we have, you'll see, we have a lot of partners in the booth that you wouldn't ordinarily expect to have to be bedfellows with AMD. But like I say, we've come quite a bit far in the last 2 or 3 years with media and entertainment. But we're anxious to show this off to you guys, and we're anxious for you to come by and chat to us. That's all I have.
We should have 2 minutes if anybody has some question. Go ahead. Yeah, I think we have one slide talking about comparing. It's just that for different scenarios, for example, right now, just now we talk about in sometimes the extremely low delay, when AV1 compared against 264, that sometimes the real scenario behind that is people want to stream to browsers. Unfortunately, some of the scenarios, the Chrome browser or Chromium-based browser do not quite support HEVC in that scenario. So in that scenario, we compare AV1 against H264. We have one slide like I presented. We do compare AV1 against HEVC. Yes. Regarding the patent, we will say that there's a lot of lawyers and patent attorneys can really address that.
Part of a larger conversation, it sounds like.
Mm-hmm.
But the cost of GPUs is quite, we've got a,
yeah, I said one side.
Exorbitant, right? So
we really do not want to downplay the hardware. It's always like the hardware, including both like dedicated silicon, LPG, and GPU-based. For example, GPU-based encoder, kind of one of the major driving force behind, for example, metaverse or cloud gaming. It's really great. And there's always hardware and software encoder scenarios. I give one example. We have a customer strongly for sports live streaming. They want to go with software encoding or the virtual machines on the cloud because they're saying that the sports not happen on every week. They have to spend a lot of cost of maintaining hardware on the stadium. So they really want to get software.
Tell you what, why don't we, they're asking us to, we could offline with this gentleman and yeah, all right. It's a fascinating discussion. Thank you guys so much.
Thank you.